Okay, so now that we've spent some time looking at summing up arithmetic series, it's now time that we move to geometric series and we look at summing all them up. Now again, these have two formulas. I don't like to think about these as two separate formulas because they really are just the same thing, just negatives of each other. But you can memorize these as two separate formulas if you'd like. You can use either one. You don't need to kind of worry about whether you can end up with the wrong answer or not. Just one of them is a little bit more convenient than the other. So we have these here. I trust that you can read them. So we'll practice applying them in a minute. We have the sum is equal to the first term times r to the n minus 1 over r minus 1, or the original term times 1 minus r to the n over 1 minus r, depending on whether our rate is greater than or less than 1. Now, our rate being greater than or less than 1 is actually a really important concept that we're about to look at in the next chapter when we look at limiting sums. So we're going to practice applying that formula. First question says to find n for 5 plus 10 plus 20 plus so on, where the sum of n terms is 315. All right, so looking at this, first thing I want to do when I look at any sequences and series question is to extract as much information as I can from the question. In this case, I'm given pretty much everything I need apart from n, which again is really helpful because that's what I'm trying to find. So I have my a. My a is always my first term, which is 5. I also have my rate. Now the rate, remember, is the rate between each of these terms. So if we're going 5, 10, 20, so on, we can see that they're doubling each time. And so our rate is 2, they're doubling. And we're also given that the sum of n terms is 315, right? And my n is unknown, and that's okay. So using this formula, my rate is greater than 1. So I'm going to use this first formula up here, which is that S of n equals a, make sure I'm right, a times r to the n minus 1 over r minus 1. All right, so what that means is that 315 is equal to 5 times 2 to the n minus 1 over, this is really convenient, 2 minus 1, which is just 1. Okay, now breaking these down a little bit, timesing by 1 obviously does nothing, so I can just forget about the bottom of this fraction. 315 divided by 5 means that 2 to the power of n minus 1 equals 63. 2 to the power of n equals 64. Now, if you think about, you could either use logs here, or if you just know your common index powers of 2, off the top of your head, you would know that this makes n equal to 6. Now, in some other circumstances, you might not get nice numbers. This is a very kind of convenient question. You might not get nice numbers. You might not get things that line up very quickly. That's okay. It just means that you'll have to use your log laws, again, which you should be pretty proficient in from your work in year 11. All right, looking at a little bit more of a practical question now. Each year when a garden is weeded, only half of the previous amount of weeds is removed. In the first year, 6 kilograms are removed. How much is dug in total over 10 years? So a couple of things are different here. Firstly, it's more practical. But the other thing is that I'm now finding the sum. I'm not finding n. Last time I was finding n, now I'm told that I have 10 years. So again, every sequence is a series question. I want to think, what information can I get out of the question? I'm told in the first year, 6 kilograms are removed. So that makes my a equal to 6. I'm also told that each year, half of the previous amount of weeds is removed. So that makes r equal to a half. You can see it's less than 1 now. So we'll use that other formula. And we're also told that our n is 10, and our sum is what we are trying to find. Now, as I said with the other questions, this kind of thing is optional to write. I find that it's helpful to write a question mark next to the thing I want to know. Right, so you're going to be using this formula now. So I'll rewrite that. 1 minus r to the n over 1 minus r. And now I just sub in everything I have. So sum of n terms, technically that should be a 10. 6 times 1 minus, and this will be a half to the power of 10 over 1 minus a half. And you can see here the reason why we use this different formula is just because it keeps everything kind of positive. 6 minus, so I'm just chucking this in my calculator, over half. Right, and so this gives me a bit of a weird number, but it gives me 11.988. So in an exam question, they might ask you to round this. Generally, I would probably round this to 12 kilograms to the nearest kilogram, depending on what they ask. And remember also that because this is a practical question, we're talking about kilograms or something, we need to answer in kilograms. So just writing an answer as 12 would not be good enough to answer the question. All right, last question. The number of members on a website doubles every day. On the first day, there were 27 members. On what day does the total number of members exceed 10 million? Okay, so again, extract everything I can from the question. So on the first day, there were 27 members. So that means that my A is 27, the first number. And also the website members doubles every day. And so that makes my rate 2. They double every time. And what I want is my N is unknown, so it says what day, but the sum is 10 million. Not the nicest of numbers, but that's okay. So coming back, I'm using my R equals 2, so I go back to using, where is it, this formula. I'm going to rewrite that. All right, because my R is greater than 1. And again, I'm just going to go back and I'm going to sub everything in, except now I'm finding N. So I go 10 million equals 27 times 2 to the power of N minus 1 over 2 minus 1, which is just 1. Really nice, right? Okay, so now I want to divide both sides by 27. So I get 2 to the power of N minus 1 equals, well, what's 10 million on 27? Gives me, I might leave it as that for now. This gives me a bit of a weird number. We're about to use some logs. So 2 to the power of N, we just add 1 to that. And this is the point where I'm going to write the exact value. Or not exact value, sorry, the approximation. Right. And so before, when I mentioned that you might need to use logs for some more difficult questions, this is an example of that. So my N now is going to be log base 2 of 370,371.3704. And again, that's approximation. But for a question like this, it says on what day. So we don't have to be entirely precisely accurate, because we're going to get an answer and we're going to essentially write on the nth day, whatever that ends up being. Now, some of you with newer calculators might be able to do this with the different base. I personally don't have the newer calculator, so I would use a change of base formula here. Now you can do log base 10 or log base E. I'm going to use log base 10. Oh, 371. It's a bit messy. 371.3704 over log base 10 of 2. Okay. Just chuck that in my calculator. And again, you would just chuck the normal expression in your calculator otherwise. And so this gives me 18.4986 days, roughly. Okay, to 4 decimal places. Now I'm not done yet. It says on what day does it exceed this? Now you got to think about, this doesn't mean the 18th day, because what this means is that 18 full days will pass, and then during the next day, we get basically halfway through the day before it exceeds that 10 million amount. And so what we write then is, therefore, it exceeds 10 million on the 19th day. And remember, with all these questions that have a practical purpose, we need to give a practical answer. So just giving an answer of 18 or 18.5 or 19 doesn't make any sense. You need to actually write, it will exceed 10 million on the 19th day.